Hello and welcome to a short video explaining how to find an intersection point using a graphing calculator. Specifically in this video we'll be entering some functions to be graphed. We'll set the viewing window to graph our functions. Then after the window is set we'll actually look at the graphs of the two functions. We'll be interested in particular with the point of intersection for the two graphs, so the next thing we'll do is we'll find the point of intersection using the second calc intersect feature of the graphing calculator. We'll look at that in detail. And then I'll also say a few things about the trace tool and why we want to avoid using that to find the intersection point of two graphs, but some of the things that we can do with the trace that it is useful for. So those are the things that we'll look at in this talk. Okay, so I've brought up my graphing calculator here, and I'm in the home screen. So the first thing we want to do is to graph our two functions. So to graph functions, we have to enter into the function editor, and that's labeled here on the graphing calculator in the upper left on the gray keys. It says y equals on the key, so I'm going to go ahead and press that key. And in the example we're working, the functions that we're looking for the intersection point are, the first function is a cost function, and that's 5x plus 45. So I'll just type that in using the keys. And then I'm going to use the down arrow or press enter to enter my next function, and my next function is a revenue function, and that's 20x. And the x variable key here is right next to the green alpha button. It's in the second row, second corner on the blue portion of the keyboard here. Okay, so that's how I enter the two functions to be graphed on the graphing calculator, and that's step one of our work. Okay, so functions are now entered. Next item. The next thing we want to do is we want to set the viewing window to look at the graphs of our two functions. So we'll do that next. So the viewing rectangle is a box that shows us where the graph of the function will be in the xy plane. So it's really a box around a portion of the xy plane that shows hopefully the graph of the function we're interested in seeing. To enter into the variables that control where that box occurs, we use the window button. So if I press window here, so what this window menu is telling me is it gives me values, x and y values, that define corners of a box that create a portion of the xy plane for which hopefully the graph of our function passes through. So when I look at the, so if you come over here in this middle row here, you'll see that here's a graph of the two functions in the current viewing window, and the box that's been set up here is based on these values here. So if I look at the minimum x value of 0 and the minimum y value of 0, then I know that the left corner of the box occurs where I have my minimum x value and my minimum y value, and in this window it's 0, 0. The maximum x value currently in the window is 10, and the maximum y value is, and the minimum y value is 0 here. So moving along the bottom of the window, the right corner of the window has its minimum y value of 0 and its maximum x value of 10. So this point is the point 10, 0. Coming up to the upper left corner of the window, that minimum x value is 0, and then the maximum y value is 200. So this is the point 0, 200 in the upper left. And then in the upper right corner of the box, we have our maximum y value of 200, and below it our maximum x value of 10. So this is the point 10, 200. So this is the viewing window that's set based on these values. Now, you typically have a good idea of what the x scale is going to be. So maybe you know that you want to graph from 0 to 10. Let's just say that that's what I want to graph. Sometimes you have to investigate the function a little bit more in detail to have a good value for the x range. So let's just for the point of discussion, assume that we know what our x range is going to be. Now, of course, to actually have the graphs of the functions appear, we need to specify a proper y range. So if we don't do this well, so for example, if I come down here on my window and I set the maximum y value to 10, and then I go ahead and I were to look at what the graph of these functions looks like. So let me, to graph the functions now, you just want to hit the graph button. So let me hit graph. You can see that I can kind of see one of the functions over here in the upper left, but it disappears out of the window, and the second function hasn't even graphed. So this is a bad window. So the question is, how do I know what y values I should choose so I can see both functions in my window and in some sense have the best fit of the two functions of the window. So I can use the window and I could sort of, by trial and error, change these y values, and sometimes if it's a quick fix, that's the fastest way to do this. But there's another feature that the calculator has available that's really useful in this context, and to access that we're going to go, instead of under the window key, under the zoom key. So let's go under the zoom key, and we're sort of moving into the next item in our talk today. So the zoom feature here is going to actually allow me to graph the two functions and get a good graph. So what I want to do here is I'm going to use the down arrow to come along the window here, and you can see me working down. And that little arrow there that points down tells me there's more, so I can keep going. And I'm going to stop here at 0. Now when you do this, if you want to do this more rapidly, if you know that it's zoom 0, you can just type the zoom key and then type the number 0 and enter, and it will take you to this feature immediately without having to scroll down to it. But I wanted to actually show you. So it says zoom fit, and so what this is going to do is the calculator says, I will take your x range, in this case from 0 to 10 is what we currently have entered, and then I'll figure out what the smallest y range of values is needed so that I can see both graphs graphed in your window over your x range. So the calculator figures out what the y window is, and this is a very nice feature and it's very useful to use. So I'm going to go ahead and just press enter here and let the calculator fit the window for our graphs. So now you can see, I can see both the first function, our revenue function, and our second function here, our cost function, in the window. The point of intersection that I'm after, we'll do that next. And also I know that my x range goes from 0 to 10. Now, of course, I don't know what y range the calculator has chosen for me. So for that, I have to go back to the window button. And you can see the calculator's chosen a y range from 0 to 200. And I can modify this if I want. So I can come back and change this if I don't like the window. Sometimes what I do is I use the zoom fit to fit the graphs to the window and then make minor adjustments from there. So that's something that we'll look at in other videos. But for now, this is good enough for our purposes. So that completes the next step of our work here. Okay, so we've set the viewing window. We just talked about that. We've graphed our function. So up next is to actually find the point of intersection. So that's what we'll do next. Okay, so with our graphs here shown in our viewing window, we're ready to find the point of intersection here that we can see here sort of in the lower left portion of the window. So to find the point of intersection, I'm going to actually have the calculator compute that for me, and the calculator is going to give me a very good estimate of the point of intersection on the graphing calculator. So to have the calculator do this, I need to enter into the calculate menu, and that's abbreviated CALC for calc. And you can see it above the trace key, and it's actually in blue. So since it's in blue, I know I need to use the blue second function to access that menu. So I'm going to hit second and then trace, but I'm actually entering into the calc menu now. And these descriptors are pretty clear. So I'm looking for a point of intersection, so it shouldn't be a big surprise that number 5, intersect, is what we want to use to find our intersection point. So we'll press enter there. And then the calculator is asking me with the question here, first curve. So is this my first curve? And yes, this is one of the curves I want to use to find the point of intersection. So I press enter once. And then it says, is this your second curve? And this is the second line. And so I press enter again. And then it says, what's your guess? Now, if you only have one point of intersection in the viewing window, then you can just press enter. If you have multiple points of intersection, sometimes you want to move the blinking cursor here closer to the point of intersection so it finds this intersection instead of maybe another intersection in the upper right. So I'm going to use the left arrow key on the calculator, and I'm just going to go ahead. In this case, I don't have to do this, but I'll show you how to do this. I'm going to put the cursor, it doesn't have to be that close, I'm just going to put it in the vicinity of the point of intersection. And if there's multiple points of intersection, you probably want to do this. And then finally, I'm going to press enter. So I'm going to actually have pressed this enter button 3 times in doing this, the third time. And now the calculator will find that point of intersection. Okay, so there it is. The x value of the intersection point is 3, and the y value is 60. And the nice thing is that the values that I'm getting from the calculator are very accurate. They're as accurate as the calculator can provide me. So they're the best guesses of the points of intersection. When the points of intersection end up being like irrational numbers, you get very good decimal estimates by doing this. So that's my intersection point for my 2 curves, and that completes the next part of our talk here. Okay, so with the point of intersection found, One of the things I wanted to do here before we finish up, we've pretty much found what we wanted to do, which is the point of intersection, but I wanted to talk a little bit about the trace tool and how we can use it, and also why we don't want to use it to find the point of intersection. So let's go ahead and look at that next. So with my intersection point from my last activity showing here in the window, I'm just going to go ahead and enter into what we call the trace feature. This is a new feature. So up here next to the zoom button and below where we entered into the calculate menu, I'm just going to type the trace key. And so what the trace key allows me to do is it allows me to evaluate function for various x values. So if I actually type an x value, so let me choose an x value of say 6. And if I press enter, it takes me to, for the current curve, which is 5x plus 45, it takes me to the x value of 6 on that curve. And then it computes the y value for me and takes it to the position on the curve, so that I know that when x is equal to 6, the value here of $75 is my cost for 6 items. To jump to the other curve, I just use the up or the down arrow keys here. I'll use the down arrow key. And it jumps to the second curve, and then I can again just type 5. And it puts 5 for x, and when I press enter, it evaluates that function when x equals 5, and 20 times 5 is 100, and that's the y value we see here on the bottom of the window. So the trace feature is a nice way to evaluate functions whose graphs are shown in a window rapidly. You can get to any x value you want, and in fact I can move along the curve if I want. I can move up here, and I can move left using the left arrow, and I can actually trace to different values. Now, let's suppose I wanted to find the intersection point using this trace tool. Well, you can see what happens here. I can get closer to the point of intersection. Now keep in mind that from the last activity we know that the exact value is 3. But you'll notice here that the calculator can give me 2.97, it can give me 3.085, but it actually can't compute that exact value of 3. And the trace feature has this limitation, and this is why you never want to use it to find a point of intersection. It just doesn't give you the values accurately enough. Sometimes you can be, depending on how you have your xmin and xmax set in the window, you might actually get lucky and the trace feature will actually give you the exact value of the point of intersection for the curve. But the thing is you can't count on that. Sometimes that happens, but most of the time this is what typically occurs. You can get close to the value, but you can't get the exact value. So if we want to get a good computed numerical estimate of an intersection point for two graphs of two functions, don't use the trace key. Use the second calc menu. You can see from what we did in the last activity, it's very fast, it's easy to do, and you get a good estimate. Now, if I wanted to verify the intersection point for the graphs of the two curves, I know the exact value of x is 3. So if I actually, in the trace key now, type in 3, that should jump me to the point of intersection. And you can see here on the 20x curve, when x is 3, it's 60. And if I jump down to the second curve and type in 3 and enter, so you can see that both curves when x equals 3 are exactly 60, and I know that that's the point of intersections of the two curves. So I can use a trace key to verify the point of intersection, but I don't want to use it as a tool to compute the intersection point for two curves. That's something we'll avoid doing. Okay, so that's it. We now know how to find the intersection point of two curves on our graphing calculator, and that ends this talk.